Alright, good day everyone. You're welcome to Biogeochemical 08 once again. Because for those of you that listen to the introductory aspect of this course, where I have to also send a video clip because I was in the class, but unfortunately I was not even aware that it was you guys supposed to be on mid-semester break then. So I decided to create a video clip that introduce the course and give us a cough about the course. So for those of you that listen to that video will have an idea of what this course is all about, and at least that will differentiate you with somebody who did not partake in this course. You should be able to tell the course is all about and what you have learned or knows so far by taking Biogeochemical 08. Like I mentioned in the class or in that clip, that the course is made up of basically these three major parts, of which the first part covers waste management and its principles, and then the second part cover bioremediation and the techniques involved, and this part where we'll be discussing biogeochemical cycles and how that is related to climate change. So we'll be discussing this. As you can see, we've been late and the time is going. I learned that the exams is approaching, so we're supposed to have our first class last week, 1st of August, and then today where we'll be covering sulfur cycle and phosphorus cycle, and probably because we can make it to next week, because it will not be distance for you guys, because you may actually need a time to revise. So I decided maybe Monday we'll make the revision and then cover the last part of the look at some tutorial questions and then call it off for the course. But unfortunately we have to make it this way. I will try and create a video clip small for each of these cycles, so that you can take your time while waiting for the CAPI period. You go through the video, and then maybe after the CAPI we'll find a time before the exam started, so we'll see, discuss, and then if you have questions, entertain the questions, and then allow you guys to study for the exams. Okay, so I will have to talk about the biogeochemical cycles. So before we talked about that, I think it's important for us to go back a little and say one or two things about maybe the history of the solar system, so that we can be able to have a comprehensive understanding of what we are saying. I think the history of the Earth formation, they said, I think geologically, how it was formed about 4.5 billion years ago, when we only have the space, the sun, and the stars moving around, and eventually they collapse with each other. So this led to formation of the well-known 8 to 9 planets we know, and we have the stars coming together to give a supernova, and then to solar nebula. After some time we have the planets, and then this planet and the sun. What is the interaction between the two is nothing but the energy, or the major elements we know in history. We say the major elements include the energy and then the matter. This is just the connection between the two. So the energy with the main source, or the ultimate source of the energy being the sun. So the sun provide the energy in form of light, and then because of the heat nature of the whole relationship. We have the heat also coming from the sun in form of the energy heating the planets. Let's particularly now say the Earth absorb the light, the energy in form of heat, take it down, because the Earth itself is in form of segments. We have the first, the surface, and then we have what we call the mantle, and what we call the core, the mesosphere, which is like the core inside the Earth. It's made up of what we call the core, and this core comprises basically of the molten ashes, the molten magma containing all those gases and the rest, the molten rocks. So, oh, time after time, there is this episode of volcanic eruption where some of the content of this coal find their way because of the increase in the heat being absorbed by the earth that is taken down, lead to this volcanic eruption. And this volcanic eruption is what constitutes of the present day atmosphere. Like on the earth here we have atmosphere, where the space between the sun and the earth comprises of some gases. So this volcanic eruption or volcanic outgassing is what provides with the gases on our atmosphere. So then these gases are basically carbon dioxide, water, hydrogen, nitrogen, sulfur, methane, ammonia, etc. Now all those gases comprises that comes from the volcanic eruption. That is prebiotic. So the atmosphere was a bit more reducing because oxygen is actually absent, and oxygen comes into being after some years in a phenomenon we call great oxidation event. And this great oxidation events happen when when this happen, the earth is not safe, because the light coming from the sun, the electromagnetic radiation, including the UV visible light, which is very dangerous, comes directly to the sun. So there was no living. So the great oxidation events happen when the life exists on the earth, because the living are actually the ones produce the oxygen. So there was no life, so oxygen is not there. So when the great oxidation events, before the great oxidation event, we have this electromagnetic radiation, including the damaging UV visible light, ultraviolet light, which comes down to the earth. But then, in addition to that, we also know that from the sun, which when you have when you segment this atmosphere, our atmosphere, it was classified or segmented into four, right? We have the troposphere, we have the stratosphere, we have the mesosphere, and then we have the thermosphere, which is more of when you go a bit closer to because the stratosphere is just like 20 or less than 20 kilometer above the earth. You have this the troposphere, and then maybe up to 50 kilometer from here, or between the 20 to 50 comprises of the stratosphere, and then from there up to about 80 to 90 you have the mesosphere. Then from there up to around 300 kilometer and above you have the thermosphere, which is more of hot zone or heat zone. So you have this classification. So the energy coming to the eight and the making the eight then is actually very very cold, not even habitable. So even when the organisms or the living exist, then they find it very difficult to survive the harsher environment. Then, so how does the life comes? And so we have this volcanic eruption, we have the formation of this atmosphere, because the atmosphere is nothing but just the surrounding containing the gases is what we call the atmosphere, which comes as a result of this volcanic outgassing. So you have this, how does the living come into being? So remember we said part of the constituent of the gas in the atmosphere include water vapor. And so this water vapor, once it comes down around the Earth's surface, it condenses. So condensing of this water vapor leads to formation of these oceans and the rivers. And evolutionary, we know of one of these evolutionary theory that talked about the evolution of life coming from the chemical reaction. So it was said that the water that is formed in the ocean on the Earth's surface, there was no living. Then you have also carbon in the atmosphere that dissolve in the water, and then the energy coming, the UVB will be high amount of energy coming and initiate a reaction between these molecules, the carbon and the rest. So you have the carbon-carbon bond, and that is when the life started. You have living organisms found in the ocean. So the living organisms now make use of this carbon that produce energy. So basically the photosynthetic microorganism or the photosynthetic bacteria now start to produce oxygen. So the oxygen is made available now in the atmosphere. So gradually this is how the evolution of photosynthetic bacteria started, and then gradually this give rise to the formation of even the complex multicellular organisms. Also evolutionary, you will get to understand that the life started actually in water, and then before it gradually complex multicellular organisms that can even survive on the land above, and then this evolution up to the organisms being able to adapt to the environment on the land, and then oxygen is being produced. So this oxygen is what rise, and then we have what we call this ozone layer. We have what we call ozone. It's nothing but oxygen, but in form of O3. So this oxygen, it rise, then it form a kind of a thin line that give a protective coverage around the troposphere, between the around the stratosphere. So between the troposphere and the end of stratosphere, we have this thin line that is called the ozone line. So the ozone layer is made of this O3, which give a protective cover. Rather, ozone around this area absorb the dangerous ultraviolet radiation. When it's absorbed, it gets split to oxygen and oxygen atom, oxygen molecule, O2 and oxygen atom. So, and it would also react back to its ozone and then also absorb. So it says that about 99% of this damaging or dangerous ultraviolet radiation is being absorbed by ozone. So in a cyclic form of absorption leading to cleavage into oxygen atom and oxygen, is what happened there continuously. It's absorbed, gets cleaved, and combined back to ozone, and like this. So any process that leads to disruption of this balance can actually lead to passing of this UV visible, ultraviolet radiation down into the earth, and what we know about this is highly damaging, and it induces cancer. So the presence of oxygen, or the evolution of the life on Earth, is what produced the oxygen, and this oxygen giving protection to that layer. So we talk about the layer shortly, and we talked about. Do we even have a time to go back there? Well, let me just say it now, that there are quite a number of chemicals that is being produced on Earth, maybe due to all this globalization. We have industrial revolution, where so many things happen on Earth due to human activities, and that interrupt or disrupt that layer, and exposing humans to all sort of damages, including the leaking of this ultraviolet radiation, causing a lot of cancers. A typical example I will give is the chlorofluorocarbon that is being used as coolants mostly in our refrigerators, in our AC, this cooling system, and this chlorofluorocarbon, that actually a gas that goes off there and disrupt the balance, or it disrupts the ozone layer, thereby reacting with ozone, and this leads to breaking of the ozone layer, and allowed the penetration of this ultraviolet radiation into the earth. So in addition to chlorofluorocarbon, you will come across quite a number of chemicals that is being introduced by humans here for some reasons, and they end up causing a lot of damages to the ozone layer, and that leads to exposing us to all sort of damage. So this is basically ozone layer, and we said found between around the stratosphere, but that's another thing. So the second reason we said the life cannot be sustained on Earth then was the fact that initially it was very cold on the surface of the Earth. So the even homeostatic balance, and then the reactions within our systems cannot be favored because of that cold nature of the Earth. So what actually happened also is there is what we call greenhouse gases. These greenhouse gases, including the carbon dioxide, majorly carbon dioxide. We have the sulfur oxide, we have the nitrous oxide, we have methane. A lot of them comprises of these greenhouse gases. And what does the greenhouse gases does was that living organisms actually absorb or collect this energy, and they release this energy in form of heat. So when this energy is released in form of heat, they collect energy rather in form of light, usage, photosynthesis, the chemicals, circulate it, use it for different purposes, and the energy, like from the famous law that the energy can neither be created nor destroyed. So we just believe that the energy and the matter were actually recycled, and the fact that the energy conservation law state that the energy can neither be created nor destroyed, but what we know that the ultimate source is the sun, and the movement is a bit unilateral, but because we can only say that the energy comes from the sun, and we use the energy, we convert it to chemical, we use it for our activities, and we dissipate the energy in form of heat, and the heat is released to the surrounding, and it goes to the surrounding and lost in the surrounding, because it goes back. When it goes back, we have these gases that give a preventive cover. So the gases, the greenhouse gases, give a cover thereby preventing those gases from escaping. So there is a way, if when these gases are too many, when those gases are too many, they prevent this heat from escaping. So the heat will be too much here on the earth. But when those gases level is maintained in such a way that they maintain the temperature of the earth, the global temperature to the tolerable limits, so that it will not interfere with some basic life supporting processes or life supporting activities. So basically, when we have a lot of those gases and trapping this heat that is going back to the sun, we have what we call global warming, or increase in the temperature of the whole globe. And we know what are the consequences of that. So basically, this is all about how global, or the concept of global warming. And what is important here is we know that when the earth come, or presently the relationship is that the energy and the matter still exist, that the energy come in a unilateral way from the sun, then we use the energy to carry out a lot of activities, because that energy is actually what is used to bring the carbon bond, and then carbon nitrogen, carbon sulfur, which give rise to human itself. And then from the other side we have a matter, and we say this matter is nothing but anything that has mass and occupies space, but we actually classify based on the properties into elements. So we have quite a number of elements. These elements, some of them are very essential to living. Just like we mentioned that a human being himself is made up of a lot of these elements that comes together. Just like we're talking about a human being made up of a lot of carbon, a lot of nitrogen, a lot of, but basically carbon, hydrogen, and then oxygen, and then we have nitrogen, sulfur, and then some other like iron, manganese, zinc. So how does these substances circulate or move or recycled between the the component of the ecosystem is what we will be discussing in the biogeochemical cycle. First of all, to what purpose are these elements, and why do they circulate, and how this circulation occur, what human activities lead to alteration in the circulation of those substances, and what are the consequences in the environment, is what is the aim of this discussion, which we will delve into. So then we define what biogeochemical cycle is. The biogeochemical cycle basically is defined as the movement of this nutrient, or rather element, between the biotic and the abiotic component of the ecosystem. What are the biotic and the abiotic component? The biotic component is actually the biosphere, and then the abiotic component comprises the atmosphere, the hydrosphere, and the lithosphere. Even though in the lithosphere is actually what we have the living, the bio individuals, and also in the hydrosphere, which you can have a little in the atmosphere. But the movement of these substances between these phases, or the component, is what we call the biogeochemicals, because they pass through the biological, geological, and the chemicals. So these biogeochemical cycles were classified into gaseous. Some of them actually involve the gaseous phase, meaning they pass through atmosphere, and then to different component: biosphere, hydrosphere, and lithosphere. And then we have sedimentary, which does not involve the gaseous form. A typical example, phosphorus, we will see. To what importance is this Biogeochemical cycle. So biogeochemical cycle is very important. Number one, we say it transfer molecules from one locality to another. So it's actually transfer molecules from one location to another. You can see a carbon here in you, and after so many years, that carbon may be found in another person, maybe geological period of time. You will see the same carbon in somebody in UK, somebody in Turkey, somebody in China, etc., etc. So it's ensure the distribution and redistribution of those elements. We have also transformation of the elements, because these elements exist in different form, and their function also differ depending on the form of the elements. Maybe you will have carbon in a gaseous form, carbon in a solid form, and their functions differ. So it ensure the transformation of this matter from one form to another. It also give a room for storage of this matter, or these elements. We have them being stored in us because they are made up of carbon, nitrogen, oxygen. So a lot of carbon, nitrogen, oxygen has actually been stored in my system. And they are also stored in form of organic matter, positive fuel in the lithosphere. Carbon is also in form of CO2, basically. Methane also been stored in the atmosphere, and we have carbon in form of carbonic acid being dissolved in hydrosphere. So they actually give a kind of a storage system of all these elements. So we have a different type of storage. There is what we call geological storage, or geological reservoir rather, and there is a cycling reservoir. We simply segregate between the the concentration, the bunch of those chemicals that is being stored and being utilized or cycled day after day, but there are those that have been stored and does not partake, let's say, actively partake in the cycling process, but they just stored. But some human activities can actually lead to the release of those and then participating in the cycle. And then we talked about it give about a distribution balance between those substances, because sometimes it is needed in high quantity, sometimes it's needed in low quantity. So it's housed in a redistribution of those. So it also give a link between the biotic and the abiotic component of the ecosystem. I used to give an example that you can have a carbon today, and over a geological period of time, you have that carbon being part of the carbon in the stool, or the table you sit it, or that particular carbon you find it in that tree. You something like that. So it actually give a link bit, and you will have a carbon part of the biological carbon that involved in all these biological processes. Have a carbon part of oxaloacetate today, and tomorrow you have a carbon part of the wood part of something else. So this is what link. That is what it says, that you by yourself made up of carbon and nitrogen and all those things, and the tree you are seeing also is made up of those same component, but only in different proportion, in a different arrangement, and whatsoever. So it links the biotic and the abiotic component. So I will stop here. Then in our next video we'll talk about carbon cycle.